Hello, friends. So today we will be discussing on the Hibernate interview questions exactly. So, what is ORM in Hibernate? Hibernate is an object-oriented mapping ORM framework for Java that simplifies the process of mapping object-oriented domain model to relational databases. ORM stands for Object Relational Mapping, which is a programming technique that enables developers to map Java objects to the database table and vice versa. In the context of the Hibernate, ORM refers to the process of mapping Java classes to the database table and Java object to the database records. Hibernate provides a set of APIs that allows the developers to map the Java objects to the database tables without writing any SQL code. Hibernate ORM work by providing a layer of abstraction between the Java application and the database. This layer of abstraction consists of a set of Java classes that represents the database table and a set of mapping files that describes how the Java class are mapped to the database tables. By using Hibernate ORM, developers can focus on writing Java code to manipulate objects, while Hibernate takes care of generating the SQL queries to persist the object to the database. This makes it easier to develop and maintain Java application that interacts with relational databases. What are the advantages of Hibernate over JDBC? Hibernate is a popular object relational mapping framework for Java, which provides several advantages over the traditional JDBC Java database connectivity for database access. Here are some of the key advantages of Hibernate over JDBC. Simplified database access. Hibernate abstracts the low-level database access code and provides a higher-level object-oriented interfaces that simplifies database access for the Java developers. This means that the developers can work with Java object instead of writing SQL queries to interact with the database. Second, increased productivity. Hibernate eliminates the need to write repetitive SQL code for every CRUD operations, create, read, update, and delete operations, which can save a significant amount of time and effort. This allows developers to focus on the building logic of their application rather than intricate size of the database access. Database probability. Hibernate provides a database abstraction layer that makes it easy to switch between different database vendors without changing the application code. This means that the application can be developed using Hibernate and deployed to different environments without worrying about the underlying database platform. Fourth, improved performance. Hibernate optimizes database access by using caching mechanism and lazy loading, which reduces the number of database queries needed to retrieve data. This can improve application performance and reduce the load on the database server. Object-oriented approach. Hibernate enables developers to work with the Java objects rather than SQL statement, which makes it easier to write and maintain code. This is particularly useful for developers who are more comfortable working with object-oriented programming concept than with SQL. Overall, Hibernate provides high-level, more productive, and more flexible approach to database access for Java application than traditional JDBC. What are some of the important interfaces of Hibernate framework? Hibernate is a powerful object relational mapping ORM framework for Java that provides a set of interfaces and classes to impact with a relational database. Here are some of the important interfaces of Hibernate framework. Session Factory. The Session Factory interface is responsible for creating and managing Hibernate session. It is typically created once per application and shared by all sessions. The session factory interface is thread safe and immutable, and it caches metadata that describes the mapping between Java classes and the database table. Session. The session interface represents a single unit of work with the database. It provides method for retrieving, saving, updating, and deleting objects as well as executing queries. A Hibernate session is not thread safe and should be created and closed for each unit of work. Transaction. The transaction interface represents a database transaction. It provides method for beginning, committing, and rolling back transaction. Transaction ensures that the group of database operations are executed automatically so that if one operation fails, the entire transaction is rolled back. Query. The query interface represents a Hibernate query. It provides method for setting query parameters and executing the query. Hibernate queries can be written in Hibernate query language (HQL), which is a SQL language that operates on Java object instead of database table. Criteria. The criteria interface provides a type-safe way of building database queries using Hibernate Criteria API. It allows developers to define query criteria based on the properties of Java object rather than SQL statement. Configuration. The configuration interface represents the configuration settings for a Hibernate session factory. It is responsible for configuring the database connection, mapping files, and other settings needed to create a session factory. These interfaces provide a powerful set of abstraction of work for working with the relational database in Java application, and they enable developers to work with objects and SQL queries rather than the low-level SQL statement. What is a session in Hibernate? In Hibernate, a session represents a single unit of work with the database. It is a lightweight, non-thread object that provides a simple interface for working with persistent object. A session is typically created by session factory, and it is encapsulates a database connection, a first level cache, and a transactional right behind support for persistent object. The first level cache in a Hibernate managed cache that stores objects that have been loaded from the database or saved during the current session. This cache is used to avoid unnecessary database queries and to ensure that the updates to the persistent objects are consistent. A session provides a set of methods for retrieving, saving, updating, and deleting persistent objects as well as for executing queries. For example, you can use session.load method to retrieve a persistent object by its identifiers, or a session.save method to persist a new object to the database. A session also manages the transactional context of its operation. Transaction ensures that a group of database operations are executed automatically so that if one operation fails, the entire transaction is rolled back. You can use the session.begin transaction method to begin a transaction and the session.commit and a session.rollback method to commit or roll back a transaction respectively. It is important to note that a session is not a thread safe and should not be shared between threads. Instead, a new session should be created for each thread that needs to interact with the database. Sessions are typically short-lived objects that are created, used, and closed within a single unit of work. What is session factory? In Hibernate, a session factory is a thread-safe object that creates and manages Hibernate session. It is a heavyweight object that is typically created once per application and shared by all sessions. The session factory is responsible for managing the configuration setting for Hibernate, including the database connection, mapping files, and other settings needed to be created a session. It is also cache metadata that describes the mapping between the Java classes and the database table. This metadata is used by Hibernate to translate the Java objects into database rows and vice versa. The session factory is typically created by reading Hibernate configuration file, which contains the necessary settings for the mapping for the application. Once the session factory is created, it is used to create a new session object by calling the open session method. Because the session factory is a heavyweight object, it should be created only once per application and shared by all threads. Creating a new session factory for for each session can be inefficient and can slow down the performance of the application. The session factory is also responsible for managing Hibernate second level cache, which is shared cache that stores persistent objects that have been loaded from the database. The second level cache can improve the performance of the application by reducing the number of the database queries needed to retrieve persist object. Overall, the session factory is a critical component of Hibernate framework that provides a thread-safe, high-level interfaces for working with the database. Why do you think about the statement session being a thread-safe object? I apologize for the confusion caused by my previous response. A session in Hibernate is not a thread safe, but session factory is a thread safe. A session is a lightweight object that represents a single unit of work with the database. It is not thread safe and it should not be shared between threads. Instead, a new session should be created for each thread that needs to be interacts with the database. On the other hand, a session factory is a heavyweight object that creates and manages Hibernate session. It is thread safe and can be shared by multiple threads without any issue. The session factory manages the configuration settings for Hibernate, including the database connection, mapping files, and the other setting needed to be create a session. It also caches metadata that describes the mapping between the Java classes and the database tables. So to clarify the statement, session begins being a thread-safe object is incorrect, and it is important to ensure that the session is not shared between threads. However, a session factory is a thread-safe and can be shared by multiple threads. What is the difference between the first level cache and the second level cache? In Hibernate, there are two levels of cache that can be used to improve the performance when working with the persistent object. The first level cache and the second level cache. The first level cache, also known as the session cache, is a cache of persistent objects that are associated with a particular Hibernate session. When you load an app object using session.load or a session.get method, Hibernate checks the first level cache to see if the object is already in memory. If the object is found in the cache, Hibernate returns the cache object rather than executing a database query. The first level cache is maintained automatically by Hibernate, and it is cleared when the session is closed. This means that the object is in the first level cache are only available during the lifetime of the session. On the other hand, the second level cache is a shared cache, and that can be used to cache persistent object across multiple sessions. The second level cache is configured at the session factory level, and it is shared by the session that are created from that session factory. When an object is loaded or saved using session, it may be stored in the second level cache if caching is enabled for that object. The next time the same object is requested Hibernate checks the second level cache first. If the object is found in the cache, Hibernate returns the cache object rather than executing a database query. The second level cache is useful for improving performance when dealing with large or frequently accessed set of persistent objects. It can reduce the number of database queries needed to retrieve or save objects, and it can improve the overall responsiveness of the application. In summary, the first level cache is a cache of persistent object associated with a particular session and is cleared when the session is closed. The second level cache is a shared cache that can be used to cache persistent object across multiple sessions and can improve the performance when dealing with the large or frequently accessed sets of persistent objects. What can you tell about Hibernate configuration file? The Hibernate configuration file is an XML file that consists the configuration settings for the Hibernate framework. It is a typical named hibernate.cfg.xml and it is located in the class path of the application. The configuration file contains information such as database connection properties, dialects, mapping files, and the other settings needed to configure Hibernate. Here are some of the important elements that can be specified in the Hibernate configuration file. Database connection properties. The configuration file specifies the properties needed to establish a connection to the database. This includes the JDBC driver class name, the URL of the database, the username and password. Dialects. The dialect specifies the SQL dialects of the database that Hibernate is connecting to. The dialect determines how Hibernate generates SQL statement for query and manipulates the database. Mapping files. The configuration file is specifying the mapping file that maps the Java classes to the database table. These mapping files defines the relationship between the Java classes and the database tables and are used by Hibernate to translate the Java objects into a database rows and vice versa. Cache settings. The configuration files can specify the cache settings for Hibernate first level and the second level cache. This includes the cache providers, cache region, name and cache strategies. Miscellaneous settings. The configuration files can also specify other miscellaneous settings such as the connection, pool size, transaction management settings, and logging settings. The Hibernate configuration file is typically needed at the start of the application to initialize Hibernate configuration settings. It is an important part of the Hibernate framework and must be configured correctly to ensure that the Hibernate works correctly with the database. How do you create an immutable class in Hibernate? In Hibernate, you can create an immutable class by mapping it is an entity sharing using the class element with the attribute mutable equals to false set. This tells Hibernate that the entity is immutable and should not be updated in the database. Here is an example to create an immutable class in Hibernate. If you can see that we can have the entity and table. In the above example, immutable annotation is used to mark the entity as immutable. The column annotations are used to map the properties to the corresponding column in the database. The @ID annotation is used to mark the primary key property, and generated value annotation is used to specify the strategies for generating primary keys. Once the class is defined as immutable, you cannot modify its properties. Any attempt to modify the properties of an immutable entity will result in an exception being thrown at runtime. This makes it safe choice for entities that should not be changed after they are created, such as historical records or audit logs. It's worth noting that the Hibernate does not support modifying immutable entities through SQL statement or SQL queries, as they are intended to be read-only. However, you can still use the immutable entity in read-only transactions or as a read-only view of the database. Please like and subscribe my channel and hit the bell icon so that you can get more informative videos from my side. Thank you.